Hey, Caitlin. I'm going to go through a couple of the problems that you asked me to. I've emailed you screenshots of the problems so you can kind of read them as you follow along. The first one is Dana has 3 hours to spend training for an upcoming race. She completes her training by running full speed, the distance of the race, and walking back the same distance to cool down. If she runs at a speed of 10 miles an hour and walks back at a speed of 2 miles an hour, how long should she plan to spend walking back? Okay, so in a problem like this, you want to set up your chart with rate times time equals distance and label the run row and the walk row. In this question, they ask about how long she should spend walking back. So for me, I would put the X in the walk time box because that's what I want at the end of the day. They also tell us that she runs 10 miles an hour and walks 2 miles an hour, so we can fill those in. And then this run time is a little tricky because we only know the total of 3 hours, and we know the portion walking is going to be called X. So what we need to put in here is 3 minus X, because that means the total time minus the walk time would be the run time. Okay, then based on the formula, rate times time equals distance, we can multiply these times each other. So 10 times 3 minus X, and then 2 times X. And then because the problem tells us that she walks back the same distance, that's a clue that these are equal. So we have 10 times 3 minus X equals 2X. And then we can just solve it from there. That becomes 30, and that becomes minus 10x equals 2x, and then we just need to get our x's together. And then we get 2.5. So we know 2.5 hours was the walk time. So if we wanted to know the run time, we could just very easily plug in 3 minus 2.5 equals 0.5. This problem didn't ask about that, but if it did, that's a real easy way to get it. Okay, the other type of problem like this that often comes up is one where they change their rate of speed when driving. So I'll do another problem like this for you. So we'll draw our box again. So we have rate times time equals distance. Okay, so in this problem, Andy took 10 hours to drive to a football game. On the way home, he was able to increase his average speed by 12 miles an hour and make the return drive in only 8 hours. Find his average speed on the return drive. So this one is set up a little different. We have an original drive and a return drive. And in this case, we know the times. We know it takes them 10 hours to get there and 8 hours to get back. And then we don't know his speed. All we know is that he went 12 miles an hour faster on the way home. And this particular question is asking about the return drive. You could put the X there. You could also put the X here. It really doesn't matter as long as you're consistent with what the problem's asking. Some people like to always put the X there, and then it's easy to see he increased his speed by 12 miles an hour. So this would just be X plus 12. Here, we just have to make sure that we get this box at the end of the day. for our final answer. So again, just like last time, because rate times time equals distance, we can multiply these. This becomes 10x. This becomes 8 times x plus 12. And then it said it was the same distance again. So we can do 10x equals 8 times the quantity x plus 12. 10x equals 8x. And then I'm just making sure I don't make any silly mistakes. 8 times 12 is going to be 96. And then we subtract. So 2x equals 96. So x is 48. So he drove there at 48 miles an hour. And then the return drive would be 48 plus 12 for 60 miles an hour. So this question is asking, what's the speed on the return drive? You'd have to say 60 miles an hour because this was the original. So just make sure on problems like that you answer the question. Sometimes people will do all this work and then accidentally give like the original instead of the return. So I can guarantee you'll see one or the other of those on the final. Okay, and then for the next ones with the fraction equations, I tried to pick ones from like former Certify problems that looked similar to the final exam ones, just to give the same vibe, just with obviously different problem or different numbers. But this one is negative 4x over 3 plus x plus 1 over 3 equals 2, and I'm going to put it over 1 just because everything else is a fraction. Since I've done a lot of these, you can see I spaced it out because usually the easiest way to deal with these types of problems is to find the LCD, which in this case between 3, 3, and 1 would be 3. Sometimes it's, you know, like if I had 3, 3, and 4, I would have to use 12, but in this case it's pretty easy. And we're going to use as a multiplier to clear the fraction. So what we're going to do is we're going to multiply each individual fraction by 3. We're allowed to do that as long as we do every single term by the same thing. It's not going to change the value, it's just going to be a more usable, friendly form. And then we need to evaluate. Okay, this is going to become negative 12x over 3, which would simplify to negative 4x. The other way to think of it is some people like to cancel those first. It's up to you, however you want to do it. This, I would always put parentheses on here because this x plus 1 is a package deal. You can't separate that. And this becomes 3 times the quantity x plus 1 over 3, but the 3's cancel, and you're just left with x plus 1. And then 3 times 2 is 6. And then this is a much nicer form to work with, and we can just combine our terms. That becomes negative 3x plus 1 equals 6. And then we can just subtract and divide. X is negative 5/3. The other thing I wanted to show you on a problem like this, and I've got a couple examples. Oops, that's a 1. If they ask about restrictions, the only thing you have to worry about is any denominator that contains an x. if the denominator does not contain an x, there's no restrictions, because no matter what we would plug in for x, we could never get a 0 down here because there's no x anywhere down there. So in this case, I don't have any variables or any x's down in my denominators, so this would be no restrictions. Okay. And then I'll do one more like that. That's similar but a little bit different. So if you have 5/4x minus 7/2 equals 4/7x. The LCD in this case, first look at the numbers between 4, 2, and 7. I think the lowest number that they would all go into would be 28. And then we also need an x because we have an x down here in some of the denominators. And so we're going to use that as a multiplier. So we'll take each individual fraction by 28x/1. And then break it down into little more sizable chunks here. This you can do, multiple ways. You can do 28 times 5 is 140, and then divide by 4 and get 35. That works. If you're a canceller, you could cancel the 4 with the 28 and get a 7. And then 7 times 5 is 35. However you get there is fine. And then the big thing is that the x's cancel. So now the denominator just has 1, and then that canceled and simplified out, so there's no more denominator. All that mess just becomes 35. And then we need to simplify the second part. 28 times 7 is 196, divided by 2 will give you 98. Other thing you can do is cancel this way and just do 14 times 7. Again, however you get here is fine. 98. And then this x didn't cancel, so it's left over. And then lastly, we've got 28 times 4 is 112, divided by 7 is 16. The canceling way would just be to cancel the 7 with the 28. 4 times 4 is 16. And then we look at our x's, and they cancel. And now we have a nice, simple equation to work with. And we can just solve from there. So I'm just going to move the 35 over. Negative 98x equals negative 19. Okay, and then negative 19 over negative 98 I guess that's just as good as it's going to get. Okay, now in this problem, if they ask for the restrictions, all we care about is any denominator that contains an x. So all we have to look at is these two. This one doesn't really even matter because there's no x, so it's not going to be part of our answer. And we just set anything with an x to 0 and see what we get. So x is 0, x can't be 0. X can't be 0. So if that was 1 on the test, it would have like the little check boxes. I have like 0, 1, 2, whatever. You would only have to fill in the 0. The trap would be to use the 2, but there's no X here, so we don't even care about that. Only denominators with X's. Okay, and the last one I wanted to do, I just noticed you missed one like this on the test. It was like one of the older lessons that you might not have seen in a bit, but it just says you're investing money, you profit $50 for every $300 you invest. How much would you need to invest in order to make $100 in profit? So I would recommend labeling your fractions when you get started. And you can do it the other way too, you just have to be consistent. So the given information is at $50 of profit, so I'll put 50 on top because it's profit for a $300 investment. So 300 goes on the bottom because it's the investment. We're just setting up a proportion here. And then we're going to have to find information on the other fraction, but they do tell us that there's $150 in profit, and they're asking how much to invest. So again, since they gave us profit, I put it on top just because of the way I labeled my proportion. And then from here, there's several ways to solve. A lot of people are familiar with like the cross multiply and divide. That's fine. And then we just solve. And you get 900. Which makes sense because 50 times 3 gives you 150, so 300 times 3 gives you 900, so that makes sense. Okay, I hope that helps. Let me know if you need anything else.